Hi everybody, I'm Wessel and this is my guide to building the ultimate stereo system, episode 3, the power supply. I'm particularly excited about this one because it's the first time that we're going to start working on any electrical or electronic items. The power supply has two different ratings, the output voltage and the output power. To determine the output voltage, I used another amplifier and I've adjusted the volume until I reach the output level that I require. And I've determined that I need a voltage peak of 20 volts. To ensure the amplifier can produce a 20 volt peak, I've chosen my power supply to be 30 volts positive and 30 volts negative. The RMS voltage of 20 volt peak is 20 multiplied with 0.707. which is equal to 14.14 volt. The output power of each amplifier is equal to V squared over R. That's equal to 14.14 squared divided by 4. I'm using 4 ohm speakers because they're more easily available than 8 ohm speakers. And that equals to 49.98 watts. I'm going to round that off to 50 watts. To determine the required capacity of the power supply, I'm going to take the output of each amplifier and the number of amplifiers. That is equal to 50 times 8, which is equal to 400 watts. The efficiency of a Class AB amplifier, like I'm building here, is around 70%, so I need to factor that in. And that equals to 572 watts. Unfortunately, I was unable to get a 600 VA transformer, but it's not really a problem because the tweeters in reality won't produce 50 watts. And they will probably only produce about 10% of that. So to recalculate, I'm going to say my required power is equal to the power of the amplifiers times 6.2. 6 fully loaded amplifiers and then the 2 for the tweeters. This is equal to 310 watts. With efficiency included, gives me 442 watts. And I'm rounding that off to 500 watts. This is a schematic for the power supply. It's a simple transformer, rectifier and capacitor power supply. The only exception is a pre-charge circuit. So the main supply comes in through these terminals. I've got a fuse to protect the transformer. I'm going to pre-charge the transformer and the capacitors through this resistor, and once everything is pre-charged, I'm going to close this relay. The transformer has two primary windings, 215 volt windings and two secondary windings of 22 volts. Goes through a normal rectifier block, and then I've got 30,000 microfarads of capacitors on the positive side of the power supply and 30,000 microfarads of capacitors on the negative side of the power supply. This is the supply proving relay. Once the capacitors are pre-charged to a point where this relay can energize, it will short out the pre-charged resistor. At that point, I will also power up a timer relay. That's a control timer relay. The purpose of this relay is to reduce or remove the thump that you hear when you switch the power supplies on. So what happens here is you have a timer that times out for all the electronics to stabilize. And once all the electronics have stabilized, then you only connect the output of the amplifiers onto the speakers. Also have an LED and resistor as a power indication light. Got the plus 30 volt output, minus 30 volt output, and then through the timer relay the control output. For the capacitors, I made this PC board. It wasn't developed, I just cut it with a saw and then scorched the copper lines to form the isolation between the terminals. I then glued the insulation of a piece of wire on the sides, and that's a nice neat assembly that I can easily mount in the enclosure. The fuse, as the relays, are DIN rail mount, which makes it easy to install. DIN rail mount simply means you've got a rail like this and the relays clip into place, so it's nice and easy to remove later on. This is the timer relay that I've chosen. It's made by Levato and it's reasonably cost effective for what you're getting out of it. The supply proving relay is a fender relay and a base, so if the relay ever burns out you can simply unplug it and replace it. This of course is the big one, the transformers, 500 VA, and it's got two secondaries. On the power supply enclosure I've already mounted the rectifier on the heatsink and also the resistor on the other heatsink. I've installed the DIN rail. I've already put two end stops in there. This is the mount for the transformer, and I've put two pieces of threaded rod into this heatsink to mount the capacitors. On the capacitors I've used this PC board as sort of a junction point, so all my connections are soldered on here. That will make it easier to wire later on. So to install the capacitors, I'm just going to push it in there and then tighten up the screws. I'm going to put nice big washers in there to distribute the force over a larger area. I'm going to tighten these just to make sure the capacitors are nice and steady, but I'm not going to over tighten it so that I break the PC board. Alright, that's nice and secure. Next is the transformer. The transformer came with a kit that's got two rubber washers and a plate to make sure that you don't get any shaving on the transformer that will later damage the insulation. I'm just gonna drop it in over like that, another piece of rubber, and then the final plate. Now this transformer is obviously very heavy, so make sure you tighten it properly. The fuse simply clips into the DIN rail. Timer relay clips onto the DIN rail, and then the supply proving relay clips onto the DIN rail as well. Before you start wiring, you just want to make sure you understand exactly where all the wires are going to run. So I'm going to install my wires through here and then through here as well, and of course straight onto the terminals there. All the connections on this project will either be soldered or lugs. To do a soldered connection, first I'm going to start by stripping my wire. It's about 8 millimeters. Turn it, then take some solder wire and tint your copper wire. Do the same with the other side. Now I'm not going to use insulation tape, so I'm going to use heat shrink. Make sure you put it over the wire before you solder, and then solder the two wires together. Slip the heat shrink over the connection, and then the right way to do this is to use a heat gun, but I'm going to use a lighter. Heat it up, you can see it shrinks, creates a nice neat insulation around the wires. Now place the wire in the area where you want to lay your final looms, and then cut it to size. Cut it, strip it. Also going to strip this around 8 millimeters. Turn it, tint the wire, tint the pin where you're going to solder to, and then solder the two together. For the lugs, I'm going to lay the wire in the area where I want my loom at the end of the day. Bring it around, cut it to size, strip it, put the lug on, in a twisting motion, and then use a crimper to crimp it together. To make the connection onto the relay, simply push the lug into the relay terminal and tighten. Okay, all the connections have been made now, and it's time to start testing. Now at this point I would recommend that you take half an hour break, come back, check your wiring again, especially with the power supply, because these capacitors can blow up and cause some serious damage. To try and mitigate some of the risk, I've pulled the supply proving relay out, and I've also disconnected the two wires onto the capacitor. So I'm going to power up the transformer through the pre-charged resistor, and then I'm going to measure the output to make sure I'm getting what I'm expecting to get before I actually connect up the capacitors. So I'm first going to measure the main supply, make sure I've got the right voltage. So that's 242 volts. It's a little bit high, but it's not bad. And now I can go close the fuse, and then I can measure the output on the rectifier. So I'm going to measure from my common to the positive, 19.6 volts, to the negative, 19.5 volts. I've reconnected the capacitor wires. I'm going to energize the transformer again and measure that I get the right voltage on the capacitors. I'm still keeping the supply monitor relay out in case I've got a short circuit somewhere. The resistor will limit my fault current. And then I can measure my DC voltages. 29.06 minus 29.12. I've now plugged in the supply monitor relay. I'm just going to check the startup sequence. I've set the timer relay to 3 seconds. If I close the fuse, that's the supply monitor relay, and that's the control relay. Once the testing is complete, isolate and make sure that you've got no supply on the main side, and also measure your capacitor voltage. Now these capacitors are very big and they can take up to 10 minutes to discharge because there's no load on them at the moment. Once you're satisfied that you're completely isolated, you can start neatening up the wires. So I'm going to do that with cable ties. You simply bundle the wires together and cable tie. So you can see why it was so important to structure your looms. It makes this step a lot better and a lot neater. So bundle the wires together, get your cable tie in there and tighten. Cable ties are complete now, and that's the completed power supply. Well, thanks for watching. I hope you enjoyed it. Please remember to subscribe if you want to follow the rest of the project, and I'll see you next time.